Hello, in this short video we're going to talk about vector addition, subtraction, and the dot product, which is one way that you can multiply vectors. To start out, let's refresh ourselves on how we go about writing and describing vectors. Vectors are variables that have multiple components, or you'll see them described as having magnitude and direction. And you'll see vectors written with the variable either in boldface type or with an arrow on top. And your vectors have multiple components, and you'll see the components noted with a subscript. So a subscript x means the x component of a subscript y means the y component of a, and a subscript z means the z component of a. And you'll see the vectors written in this bracket notation or with the unit vectors. So x with a caret means the x direction, y with a caret means the y direction, and z with a caret means the z direction. If you want to find the magnitude of a vector, the magnitude is written with the vector in the absolute value signs, or just the symbol without the boldface or the arrow. And the magnitude is just an extension of the Pythagorean theorem. You do the x part squared plus the y part squared plus the z part squared, all under the square root. The important thing to note is when you're manipulating vectors, you're looking at what's going on with the components. So when you're adding or subtracting vectors, you always have to do it component by component. So a plus or minus b means ax plus or minus bx, that in the x direction, then ay plus or minus by, then az plus or minus bz. And you always keep your x's, y's, and z components all separate. You may also see vector addition and subtraction done graphically. This is called the head to tail method. What you do is you draw your first vector, which I've done here in red, and then your second vector, you start at the tail of the first one, and so you start your second vector at the end of vector A, and then the result is the base of the first vector drawn to the end of the second vector, so a plus b as shown in that image. You can also multiply vectors. There's two ways of doing this that have different mathematical and physical meanings. The first way is a simple way. It's called the dot product. You'll also see this written as a scalar product. This is where you multiply two vectors and the result is a scalar. And again, this is done in terms of components. And so you'll see a dot b is ax multiplied by bx plus ay times by plus az times bz. And again, this result is a scalar, which is just a single value. So you're collapsing these two vectors down into a single value. Again, it's just ax times bx plus ay times by plus az times bz. You'll also see the dot product written in terms of the magnitudes of the vectors and the angle between them, because your dot product will also equal the magnitude of A times the magnitude of B times the cosine of the angle between the two vectors. But if you're not sure about what to do, you can always fall back on the first definition. The dot product in terms of the components is the most fundamental one. The nice thing about this dot product is, again, it gives you a scalar, but you can also interpret what the two vectors are doing based on the sign of the dot product. So for example, when you have a dot b giving you a positive value, that means the two vectors point in somewhat similar directions. Not necessarily parallel, but they're both kind of going the same way. Likewise, if a dot b is negative, that means the vectors are at least partially pointing in opposite directions. And most importantly of all, if a dot b is equal to 0, that means the two vectors are perpendicular to each other. So important thing to remember there. So thankfully it's a pretty straightforward process. I'll be posting another video on the cross product, which is the other way of multiplying vectors.